Hi everyone, welcome to our video lesson today. What we're going to be doing is we're going to be proving lines parallel. The way we're going to be doing that is using a lot of the same angle relationships that we've been talking about in previous video lessons with the alternated interior, corresponding, all those relationships. So this is lesson 3-5. The first thing we're going to do is we're going to copy this angle. And the way we're going to copy this angle is by using our compasses and straight edges. So if you have one of those, please take that out. If you don't have one of them, please just watch, and then maybe when you get to class the next day, you can practice this on your own. So we're first going to draw a ray, and that's going to serve as one of the sides of our new angle. So there's a ray. Now what we're going to do is we're going to take out our compass, and we are going to put our needle of our compass on the vertex of the angle. We'll open up our compass, and we're going to draw an arc that intersects both rays. So both sides, right there and right there. And now we're going to use this same compass setting, and we're going to go to the end point of this ray, and we're also going to draw a decent size arc with that same compass setting. It's for sure going to intersect this ray. And then make it pretty decent over here as well, pretty decent size. Now that we have that, what we want to do is we want to get the distance from one intersection to the other intersection of where the arc intersected the angle, the rays of the angle. So let's put our needle at one intersection, and let's open this up so that we can get our pencil at the other intersection. Once you have that, you're going to go to this intersection of the ray and the arc, and you are going to make an X, or you're going to make another intersection of these two arcs. So just like this. And now that we have that, we can take our straight edge again. We can draw another ray. This is going to be the end point, but it's going to serve as the vertex of our new angle and go right through the intersection of what we made with those other two arcs. And we have successfully copied that angle. So what's happening here now, if we measure this, and let's say we get this angle to be 135 degrees, this angle would also be 135 degrees. Or whatever the angle is, it'd be congruent to the other one. So, with knowing that, let's do the same thing here, creating corresponding angles and make them the same or congruent to each other. So there is 4 angles up here. Any one of them I can copy. What I'm going to do is I'll probably just copy this one. Okay? So when I copy this one, and I'm going to have it be copied with this being the vertex, that purple dot right there. Oh shoot, no, it's gone. Well, now I'll make it green. That's going to be the vertex of my new angle. So what I'm going to do is I'm going to take my compass, put the needle at the vertex, and I'm going to draw an arc that intersects both the red line and the blue line. And I'm going to use this same compass setting. I'm going to intersect the blue line for sure, and then I'll go down to right about there. Now what I want to do is I want to get this distance of the angle. So put my needle at one intersection, put my pencil at the other intersection. So I'll have to close it up just a little bit. There we go. Now I'm going to put my needle at this intersection and make that X with my other intersection, just like this. Now I'm going to take my straight edge, and I'm going to draw a line that goes right through my green dot and right through my intersection, right about there. And then I will extend this line so you can see it a little bit better. So just a question for you. What do you notice about the black line that I drew on here and this red line? So this line and this line. What do you notice about them? They look pretty parallel, don't they? It looks like if they continued forever and ever and ever, that they would never get any closer to each other and never any further away from each other. So these two lines are parallel if this corresponding angle is congruent to this corresponding angle. So what's happening, class, is it's kind of a reverse lesson from a few days ago. A few days ago we said if lines are parallel, then corresponding angles are congruent. Now we're saying that the converse is also true. If you switch around the if and then statements, if corresponding angles are congruent, then lines are parallel. A few days ago we said if lines are parallel, then the alternate interior angles are congruent. Today we're saying the converse of that statement. If alternate interior angles are congruent, then lines are parallel. And same thing for these other two properties as well. If alternate exterior angles are congruent, then the lines are parallel. And if consecutive interior angles are supplementary, then the lines are parallel. So what we just did is we had all those same statements from a few days ago, and we found that the converse was also true. If we wanted to, we could now write the biconditional, because the biconditional uses if and only if, when the converse and the conditional statement are both true. We won't do that today, but we could. So now we can solve some problems. We could say find x so that m and n are parallel. Right now it clearly doesn't look like m and n are parallel. They're going to intersect. But find x so that they are parallel. So what I want you almost to envision right here is that this line looks more like this. Okay, m and n are parallel. I know that that's not what it said, that's not what it looks like, but we're supposed to find x as if they were. So how would we set this one up? Well, if they're parallel, we could say that corresponding angles are congruent. So corresponding angles would be this one and this one. So they would both be 3x plus 25. Now we can clearly see these two form a linear pair. So they would add up to equal 180 degrees. Or we could say this. If lines are parallel, alternate interior angles are congruent. So this 6x plus 2 and this 6x plus 2 are both alternate interior angles. And now again, it would be very easy to see that this 3x plus 25 forms a linear pair with this 6x plus 2. So we could set them, add them up and set them equal to 180. Or of course what we can just do with this given information, we were given this and given this, they are consecutive interior angles. And consecutive interior angles are supplementary, which means that they add up to equal 180. So that's how we're going to solve this one. 3x plus 25 plus 6x plus 2 add up to equal 180 degrees. Even though both of these angles clearly look obtuse, there's no way two obtuse angles could add up to equal 180. You're not going to go by what it looks like. You're going to find x so that m is parallel to n, which means that they're going to be supplementary. Alright, let's solve. 3x plus 6x is 9x. 25 plus 2 is 27. That equals 180. Let's subtract 27 from both sides. So 180 minus 27 is 153. And then divide both sides by 9. So 153 divided by 9 is 17. So this is our answer because it just says solve for x or find x. But if I wanted to find the angles, of course I would just substitute 17 into there and substitute 17 into there. Next one, find x so that line M is parallel to line N. So once again, if M is parallel to N, that means alternate exterior angles are congruent. So this angle equals its alternate exterior angle, that one. So 6x plus 10 equals 8x minus 10. If lines are parallel, alternate exterior angles are congruent. Solving for x, let's subtract 6x and add 10. So 20 equals 2x, x equals 10. There we have it. We solve for x knowing that line M is parallel to line N. We finished the video lesson with 3 problems that look like this. If line 1 is congruent to, if angle 1 is congruent to angle 12, which lines are parallel? Which lines can we prove to be parallel? Well, if 1 is congruent to 12, I don't know why I did 2 arcs in that one. If they're congruent, they would both have 1 arc. We can say that letter E, or line E, is the transversal. So if E is the transversal, what 2 lines does E intersect? It intersects K and Y, doesn't it? So we can prove that K and Y are parallel if 1 and 12, which are alternate exterior angles, are congruent. So the lines that are parallel are K and Y. Next one, how about if 11 is congruent to 15? So here's angle 11, and here's angle 15. Well, these 2 angles are corresponding angles. So if corresponding angles are congruent, we have a set of parallel lines. So let's now see what the transversal is. The transversal is the line that intersects both angles. So this line right here, line Y, is the transversal. So if that's the transversal, what 2 lines does Y intersect? It intersects line E and line L. So E and L are parallel to each other because 11 and 15 are corresponding. Last one, what if 10 is congruent to 16? If 10 is congruent to 16, well, what relationship are 10 and 16? They're not corresponding. They're not alternate exterior. They're certainly not alternate interior. 10 and 16 are consecutive exterior. And consecutive exterior angles, if lines are parallel, then consecutive exterior angles are supplementary, not congruent. So we can't prove anything about any parallel lines up there. In fact, more than likely they're not parallel if 10 is congruent to 16. So this one, which lines are parallel, we can't prove that any are. None. Okay? There's no such relationship for consecutive exterior angles being congruent. That's not one of our proofs for proving lines parallel. Let me know if you have any questions on this lesson when you get to class tomorrow.